Hi, my name is Gabriela de la Fuente, and this is my molecule of the year, guanine. So let's get into it. Guanine was originally used as a fertilizer as it was discovered in the oddly disgusting crevice of bat guano, which is what gave it its name. While it was combined with other biomolecules at first, it was eventually isolated in 1891. Its discovery is accredited to multiple scientists such as Julius Bodo Unger and Phoebus Levine, which makes it difficult to pinpoint exactly who discovered the biomolecule first. So the physical properties of guanine. Its molecular formula is C5H5N5O, as you can see in the molecule in the center. Its molecular weight is 151.13 grams per mole. Its melting point is 360 degrees Celsius. Its boiling point is 591 degrees Celsius. And its molecular structure is a fused ring system with double bonds. Guanine's molecular structure is more specifically a fused pyrimidine and imidazole ring system with conjugated double bonds. And while this may sound super sciencey, this basically means that one of the rings is a hexagon shape, as seen in the pyrimidine, and the other is a pentagon shape in the imidazole. Guanine's molecular geometry is planar to help with stabilization within the molecule, as we can see in the intermolecular forces. Because of guanine's unique traits, we can see this molecule benefiting within its own interactions. The main network of covalent bonds helps guanine stack itself, and it allows the electron density to be dispersed in stable ways. This is especially important when we look at the repeating patterns of DNA and utilization of space within DNA molecules. So because the molecules are being stacked on top of each other, it leads to much efficiency and space. So the chemical properties of guanine. Guanine can form 3 bonds of hydrogen to bond with its partner molecule, cytosine. Cytosine and guanine are best friends because they're always together within the DNA molecule, and their bond is slightly stronger than the other molecular bonds of adenine and thymine and adenine and uracil because of the 3 hydrogens that are shared. Secondly, guanine is a key part of life. Because all life on Earth uses genetic material, guanine is in every living thing. It is absolutely crucial for us to exist, because if we didn't have it, we wouldn't be us. So for this reason, guanine is super important, and I'd like to nominate it as a hero. Because if you think about it, guanine has survived millions of years of evolution in every living thing. And that's a pretty monumental achievement that this humble biomolecule lives with every day. Not only that, but guanine possesses the code that makes us, us. It contains all of the code for our bodies to function and helps carry those instructions for our bodies to carry out on a cellular level so that we can continue more important tasks at a much larger level. So what if we didn't have guanine? What if it didn't exist within us? Well, guanine already ensures that our biological processes are carried out correctly, and if they aren't, this can lead to many complications at a cellular level. Some examples of this would be deletion mutations, which is when a gene is missing within a DNA sequence. Because of this, this can lead to syndromes that delete significant parts of the chromosome, and they can range from potentially harmless to detrimental. Looking at deletion mutations, we can look at DiGeorge syndrome, which affects chromosome 22, and its deletion leads to problems within one's immune system, such as heart problems and head and neck abnormalities. Another one is Prader-Willi syndrome, and it's a deletion mutation that leads to disruptions within the hypothalamus, which is critical for hormone regulation, as it also controls hunger and fullness cues. It can lead to intellectual disability and disruptions in the signal that communicates hunger to the brain. This can lead to overeating and obesity in early life stages, especially infancy. And lastly, that we'll be looking at is Angelman syndrome. It's a deletion mutation that's also in chromosome 15, but this disorder leads to severe intellectual disability and delays balance and locomotion issues. So, as a conclusion, guanine is super important to us, and without it, we would be significantly affected. Because of all the things that it does for us, I think that guanine should be declared as a hero and should win the Molecule of the Year award. And lastly, these are my references. Thank you so much for listening, and I hope that you take guanine into consideration as Molecule of the Year.